Networking, a Web 110 final project effort. Have you ever considered how computer users are able to use technologies to send emails, share files, and collaborate to enhance productivity? Have you heard about hardware devices and cables such as routers, switches, and Ethernet and wanted to know more about how it all works together? This presentation will provide fundamental knowledge to network hardware, cabling, and common protocols for network communications. While beginning research for the final project in networking, I found this thought-provoking image of 4 separate thought bubbles. While various network components may appear distinct, the goal of this presentation will be to connect these components, switch, router, cable, and protocols, and present them as a complete image, similar to a completed puzzle. What is computer networking? Computer networking refers to interconnected computing devices that can exchange data and share resources. Networked devices use a system of rules called communications protocols to transmit information over physical or wireless technologies. A network node may be data communication equipment such as modem, hub, or switch, or data terminal equipment such as 2 or more computers and printers. First, the network hardware device, switch. The network switch connects devices in a network to each other, enabling them to talk by exchanging data packets. In a local area network using Ethernet, a network switch determines where to send each incoming message frame by looking at the media access control address. Switches form the majority of network devices in modern data networks and carry huge amounts of traffic in telecommunications provider networks. Switches provide wired connections to desktop computers, wireless access points, printers, industrial machinery, and some Internet of Things IoT devices such as card entry systems. Next, another network hardware device is a router. Routers guide and direct network data using packets that contain various kinds of data such as files, communications, and simple transmissions. Data packets have several layers or sections, one of which carries identifying information such as sender, data type, size, and most importantly, the destination Internet Protocol address. The router reads this layer, organizes the data, and selects the most effective route for each transmission. Now that we've discussed or talked about 2 common, frequently used network hardware devices, let's move forward to talk about how we connect these devices to the network. Network cabling standards, Ethernet. Ethernet cable allows the user to connect their devices such as computers, mobile phones, routers, etc. to a network that will allow the user to have internet access. Cable networks primarily use Ethernet twisted pair, which consists of copper wire cable in which 2 insulated copper wires are twisted around each other to reduce interference. This interference could includes electromagnetic interference and RFI or radio frequency interference. A second type of Ethernet cable frequently used in networks is fiber optic. Optical fibers made of glass cores surrounded by several layers of cladding material transmit data in the form of light signals due to which there are no interference issues in fiber optics. Transmits signals over very long distances as opposed to twisted pair or coaxial. In a previous course, Net 111, A+ Hardware, Module 5, Network Fundamentals, the course textbook discussed different Ethernet cabling specifications. Opening an Excel spreadsheet, I entered the data for Ethernet cabling specifications to develop a fundamental understanding of how Ethernet specifications and these technologies work. You can see cable type or category, Ethernet specification, maximum speed, maximum distance, and nodes. You'll see that I have highlighted category 5E, category 6, category 6A, and yellow highlight. Note that category 6 and category 6A both have maximum speeds of 10 gigabits per second. Note, however, that category 6 has a maximum distance of 55 meters, or about 180 feet, and category 6A has a maximum distance of 100 meters, or about 328 feet. Category 6 and category 6A are the two strongest contenders that you would want to consider when implementing a physical network. Now that we've talked about switches, routers, Ethernet cabling, you might be asking, how do all these components connect together in your network? This is where the network topology comes into play. Network topology is the physical and logical arrangement of nodes and connections in a network. Usually include devices such as switches, routers, and software with switch and router features. With well-defined and planned out network topology, an organization can more easily locate faults and fix issues. Here you see 6 common physical topology installations or implementations. 3 I would like to recognize will be the bus. You see 4 separate computers or devices connected to one central cable. One risk with this implementation topology is the computers connected to one central cable. If the central cable in the topology breaks or gets damaged, the whole network could go down. Next, the physical star topology. Here you see a series of 5 separate computer or devices connected each with their own cable to the central hub. This provides some degree of network resiliency, meaning if any one cable breaks or is damaged, only that computer or device is affected, and the rest of the network is able to continue. This can be thought of as in a hub and spoke formation, similar to that of a bicycle wheel. Thirdly, there's the mesh physical topology. You see a series of 5 separate computers or devices, each interconnected, one computer or device to each other computer or device within the network. This provides a high degree of network resiliency and fault tolerance. However, with that increased fault tolerance comes an increased cost. Moving forward, network protocols. A network protocol is an established set of rules that determine how data is transmitted between different devices in the same network. Network protocols make it possible for devices to interact with each other because of predetermined rules built into the device's software and hardware. One of the most frequently used is Dynamic Host Configuration Protocol. DHCP is a client-server protocol that automatically provides an Internet Protocol host with its IP address and other related configuration information such as subnet mask and default gateway. For users of Windows operating system, if you run command prompt and enter ipconfig, you can find this information on your command prompt window. For classmates who might be using Mac OS or Linux operating systems, the command you would run would be ifconfig. A second commonly used network protocol is domain name system. Domain name system is a process that allows Internet users to navigate the Internet using host names instead of numeric IP addresses. Domain name system is frequently referred to as phone book of the Internet. Think about it this way. When browsing the web, you're able to type harper.blackboard.com or amazon.com or mail.google.com for simplicity and ease of remembrance. Think about what would happen if you had to remember a series of numbers for the Internet Protocol address to access these websites. Without domain name system functionality, the Internet will be a much less useful and productive technology. In a previous course, Net 111 A+ Hardware, Module 6, Introduction to TCP/IP, the course textbook discussed frequently used network protocols. Here you can see in the Excel spreadsheet domain name system, dynamic host configuration protocol, and hypertext transfer protocol secure, or HTTPS. Hypertext transfer protocol secure helps to encrypt the traffic between the server and the client. HTTPS works closely with secure sockets layer or transport layer security. HTTPS working in conjunction with transport layer security works to provide what's called a digital certificate. You can see here from a previous course, the Internet Security Unit, a digital certificate in action. Upon careful examination, you can see the issuer name and the dates of validity issued on and expiration date, and the public key information. In conclusion, the goal of this presentation was to connect the seemingly distinct and separate network components, the switch, the router, Ethernet cabling, and network protocols, and bring it together as a completed image, similar to that as a puzzle, similar to an image of a completed puzzle. Thank you.